Yeah. Let's say today we'll discuss about elastic load balancing. Elastic load balancing, or we can call as ELB. Okay. So what is the purpose of ELB is if we want to build a high available, high scalable application, we require a load balancer. What load balancer will do in the like AWS is whenever like we are getting a traffic from the user, it will take that traffic from the user and redirects or distribute that network traffic to the healthy instance at any point of time. With this, always the user will get the working application itself. So the user need to connect to the healthy instance at any point of time. Who is taking that load balancing decision? A load balancer is going to take that load balancing decision in order to redirect the user traffic always to the healthy instance. Okay. So now we have the different types of AWS load balancers we have. But if someone asks about ELB, ELB takes the ELB takes the user traffic and it distributes the traffic to improve that application high availability. What is the main advantage we have is, okay, so what is the main advantage is always the application is highly available to the users. Okay, always the application is highly available to the users, whereas ELB automatically distributes the traffic across the multiple targets and virtual appliances. How we are going to create those multiple targets in AWS, how we are creating those multiple targets? We are using maybe EC2 auto scaling. Then what load balancer is doing is it's distributing the traffic to multiple like targets. And whenever we want the high availability, always we need to choose those targets in one or more zones. It's not only like one zone. Better to go for two or more available zones. But here a small point is there. The scope of ELB in AWS is a region itself. That means we can do the load balancing. We can do the load balancing only at the region level. That means if I have multiple regions, by default, AWS load balancers can't perform load balancing. Okay, that means I have two regions. Okay, I want to do the load balancing. That load balancing is not possible as of now by ELB. We have other techniques that we'll discuss. But as of now, the scope is only within the region. And in region spread across multiple available zones, we need to keep our instances. That means whenever you are creating the EC2 instances, always make sure our EC2 instances spread across multiple zones. Then what is the main advantage is even if zone goes down, okay, another zone instance, who will take care of the load balancing decision? Who will take care of that load balancing decision? A load balancer will redirect the traffic. Okay, but what is going to happen if my zone completely goes down?
Other zone.
Yeah, another zone should be there, but load balancer can't do that. Okay, so we require one more component. Okay, that's at the DNS level will do. Any idea? What is the AWS DNS service name? What is the AWS DNS service name? The Route 53 is the AWS DNS service name. So Route 53 is our AWS DNS service name. So we need to use Route 53 in order to redirect the traffic between multiple regions. But as of now, ELB, Elastic Load Balancer, only can redirect the traffic within the region itself. But is it recommended to use only one zone or more zones? What you will recommend while designing our application, infrastructure design?
More zones.
Yeah, more zones is recommended. What is the advantages?
If one zone goes down, another zone.
Yeah, one zone goes down also. The solution is highly available from the another zone. The solution is highly available from the another zone. Okay, if you want to redirect the traffic between the multiple regions, then for what service we need to go?
DNS.
DNS.
DNS, we need to go for that. So if you go for the DNS, what is the DNS service name in AWS?
Route 53.
Yeah, Route 53. Any idea why it is called as Route 53? The DNS port number is 53. That is the reason AWS kept the name as Route 53. Okay. So this
Okay.
we'll discuss on the AWS Route 53 when we are discussing. Now, already we discussed ELB. Okay. So what is your definition of ELB? ELB will distributes the user traffic to always healthy target. In our scenario, what is our target in our use case as of now? It's EC2 instance. Okay. So for the high availability, we are going to create multiple EC2 instances, but those we are not created manually. We created better to create through auto scaling groups. What is the advantage of creating them through auto scaling group?
We can maintain it.
Yeah. Say suppose even it depends upon the load. Say suppose the front face is a load balancer. You may have a minimum 2 to 1,000 instances also. But end user doesn't know those instances. Who knows to which instance it need to redirect? Who will take that decision? Load balancer will take the decision. Load balancer will take the decision by redirecting that user traffic to that instances. The 2 to 1,000 instances have been created by those 2 to
Auto
1,000
scaling.
instances. Yeah, those have been created by auto scaling. Load balancer acts as a front face kind of thing. Any idea what is there before load balancer? Okay, so before load balancer, we will have our domain name. Any example you know? Maybe flipkart.com. Okay, so like this, we have the domain name. Then Route 53 will redirect to your load balancer, and load balancer backend we are going to have multiple instances. And these 2 to 1,000 instances, how we have created? Using auto scaling groups. Using auto scaling groups, and backend to that, even we'll have the RDS, and RDS also will keep in multi-agent environment. That means we are going to keep even the database also in the multiple zone. Then in this use case, can you guess if one zone goes down, the solution is highly available or not?
Yes.
Yes. Okay. Load balancer will use another zone instance and another zone database. In this use case, if the complete region goes down, what is going to happen? Completely, it's a single point of crash. For that, we need to use the Route 53. Then we need to create one more load balancer in another region. Then auto scaling, RDS also. Then here one point is there called as replication. That means one region data we need to replicate into another region also. So how to replicate at the EC2 level, we can use AMIs or snapshots also. At the RDS level, how to replicate all these also going forward, we'll discuss. But who is going to switch the traffic? One region to another region? Route 53 is going to switch. But within the region, who is going to take the decision? Within the region, who is going to take the decision?
Load
Balancer will take. Okay, so now in AWS load balancers, what are the types of load balancers we have? We'll discuss. What are the types of load balancers? Everyone should be able to tell the types of load balancers. In AWS, we have 4 types of load balancers. Okay, so that E stands for elastic load balancers. Okay, the first one is classic load balancer. This is called as old generation load balancer. Okay, so this is called as old generation load balancer, and already AWS has been declared end of life for this load balancer. Okay, so what is that classic load balancer we'll discuss, but anyhow today we are not going to use classic load balancer. And the second one is we have network load balancer, and the third one is we have application load balancer. The fourth one is gateway load balancer. Say among these, previously, like maybe 4 years back, 5 years back, you can tell you have used classic load balancers, but currently we are using network and application load balancers. But we have a new way of using one more load balancer is there, that is called as gateway load balancer. But mainly we are using
Network and application.
network and application. What are those differences? We are going to discuss, and already end of life have been declared for
Classic load balancer.
which
Classic load balancer.
say classic load balancer, that is the old generation load balancer. There is no use of classic load balancer as of now. Most of them already migrated to either network load balancer or application load balancers. Okay, so these all the four types. So for our project or for our application, we need to design which load balancer suits for like our requirement. We need to discuss. Okay, so then here the use case is. Okay, so as of now, try to understand the backend targets. As of now, our understanding is, as of now, the backend targets are healthy EC2 instances, or we can use IP addresses also instead of instances. The third one, we can use Lambda also for the serverless applications, or ECS. ECS is container service, or Kubernetes also. These workloads also are the targets. But as of now, our understanding is only for EC2 instance. And those EC2 instances, either we can create individual VMs or we can create auto-scaling groups, which is recommended for the real-time auto-scaling groups. Instead of managing always the individual VMs, better to go for auto-scaling group, and that has been to be attached to your load balancers. Okay. So what are the backend targets? Even we can use the serverless kind of thing, and even containers also, and even with the hybrid on-premises infrastructure also, we can do the load balancing using the gateway load balancers, all these. Okay, so there would be a lot of cost can be reduced. Okay, say even say here, if you see 90% of their infrastructure cost also have been reduced by using a load balancer. Okay, that is the main advantage. And always the application is highly available or not?
Yes.
Always the application is highly available. So now here we need to understand how this load balancing works. Okay, so just go through here. We have the video also. So when we use the load balancing with auto scaling, when we use the load balancing with auto scaling, what is the advantage?
Cost cutting.
Okay, yeah, main cost cutting, and right size of images or right size of instances we can maintain. Okay, and always the solution is highly available. Fault tolerant kind of things also is going to take care. So we need to create the auto scaling. Okay, we need to configure this terminology. We'll discuss. So first I'll explain about the application. Okay, so now here we have elastic load balancer automatically distributes incoming traffic from the EC2 instances, containers, and IP addresses also. Okay, so then here we have the components. Okay, so what is the component is? What are the components we have? A load balancer, like is a physical or virtual load balancer. What is the AWS is providing for us? It's a physical firewall or virtual firewall? Sorry, physical load balancer or virtual load balancer?
Virtual load
The
balancer.
virtual
Virtual
itself. Okay, it acts as a single point of contact for our applications. Then all the end users also will access this load balancer itself. Then load balancer redirects the incoming traffic. But in this use case, we are discussing. In this use case, we are discussing application load balancer, and this terminology is mostly common with any of the load balancer. Okay, so then here we have a listener. What listener will do is, okay, so whenever like a connection comes from the client, it uses the protocol and the port number and verifies whether that target is listening or not. Okay, if the like a listener having a protocol and port number, and in that protocol and port number, it's continuously probing. If there is no response from the target, what load balancer will assume?
Server is dead.
It's assume load balancer will assume it's unhealthy and it doesn't redirect the user traffic to the unhealthy instance. Always load balancer is going to redirect, okay, to the healthy instance itself. What listener is doing is, on behalf of us, we have 1,000 servers. Each and every time we can't check the server health on behalf of us, that listener is doing. That means indirectly, load balancer itself is keep on probing. What it is probing to the target, whether that is listening on that particular port number and protocol. If that is not listening, it assumes that instance is removed from the load balancer and doesn't redirect the user traffic to that. Okay, then here we have a target group. And what is the purpose of target group is, always target group will, like we have the group of instances in AWS scenario, that multiple EC2 instances, we are going to group them into multiple servers, and we are going to register the target with multiple target groups also. That means in our scenario, if you have 2 to 1,000 instances, all those 2 to 1,000 instances also we can group them into one target group, or we can have the multiple target groups also. Okay, what is the main advantage is, okay, if you have two applications, you can group them into two different target groups. Okay, so that means in one target group, what we can have is multiple EC2 instances. Okay, so multiple EC2 instances or multiple Lambda kind of functions or containers or Kubernetes also we can have. So in this use case, now here we have a load balancer, we have one listener, here listener, and we have the how many target groups in this example?
First one is 2.
Yeah, we may be having 3 target groups. Okay, say 3 target groups. One server, say here, say as of now, technically here we should have 6 targets, right? But one target have been resides in 2 different target groups. Okay, so then here we have I'll tell one example. Say I have one application. Maybe we have a like banking portal. Okay. So for banking portal, for car loans, all these, I want to have one system. Okay. For home loans, I have another system. Okay, another application is there. Okay, so for maybe like gold loan, I have another system. That means I have three different applications. I want to take car loan application is on 10 servers and home loan application maybe on 10 servers. Gold loan server is also on 10 servers that can be auto scaled to 1000 also. Then in this use case, how many target groups I'm going to keep?
Three,
Three.
sir.
Three target groups we are going to keep. In each target group, we can have 2 to 1000 servers and load balancer will take the decision of based on the user request to which target group also. Here I'll tell one example. So now here assume ICICI bank.com. If I use slash car loan, I want to redirect to car. Okay. If I use slash home loan, I want to redirect to home loan slash gold loan. Okay, that this is called as okay, path-based routing. Here ICICI Bank is our domain name, but we have the multiple.
Yeah,
We have the multiple path. Depends upon the path. I want to redirect the server to the different targets. Then I need to use. Then I need to use path-based routing. Okay, so this called as path-based routing. Okay, path-based routing is supported by application load balancer itself. It's not supported by network load balancer. Okay, and path-based routing supports HTTP and HTTPS traffic. Means mostly for the web-based applications, it is going to be network load balancer. Network load balancer, say it supports other than not only HTTP or HTTPS, it works at TCP and UDP level. But only for the web-based applications, if you have path-based routing, URL-based routing, content-based switching, all these are possible by using the network load balancers. By using the network load balancer, it is going to be supported. Okay, for TCP and UDP kind of data, if you want to transfer, say, suppose I want to do 2 DNS servers, or 2 DHCP servers, or 2 Active Directory. Otherwise, I have like maybe 2 MySQL kind of servers. These all not possible by. These are not possible by application load balancer. It's only for the web-based applications only. Web-based applications only, application load balancer is going to be supported. Whereas network load balancer, not only for HTTP, HTTPS, TCP, UDP level also it can support, but path-based routing, URL-based routing is not possible by
transport layer, network layer.
Yeah, say by the network load balancer. Okay, then application load balancer works at layer 7 in the ISO OSA model. Network load balancer works at layer 4, but you don't tell only this difference. So we need to tell minimum 5 to 7 differences. In this, the first one is application load balancer works at layer 7. Network load balancer works at layer 4. TCP, UDP level network load balancer supports path-based routing, web-based applications. All these have been supported by application load balancer. And application load balancer can be integrated with the web application firewall and user authorizations, Cognito kind of those also is supported. What is this? We'll discuss. Web application firewall will provide for the web-based applications like bot protection or XML, SQL kind of injections, CSS kind of injections. From all those, it is going to provide the support. Okay, so that's Cognito is used for user authorizations, authentications, but these two not supported by network load balancers. But another advantage with the network load balancers is millions of requests per second. Also, it can redirected by the network load balancer. Millions of requests can be handled by
Network load balancer.
network load balancer. Okay, millions of requests also can be handled by network load balancer. That is the reason even we can use a network load balancer. Okay, that can be redirected to multiple application load balancers also. Okay, so then what are the targets? Application load balancer, I'll use ALB as application load balancer. What are the targets supported is EC2 instances or those IP address or containers or Kubernetes or Lambda also. Okay, whereas targets for NLB is okay for network load balancers. Okay, EC2 we can have, or we can have IP address or containers or Kubernetes also, means EKS itself, but Lambda is not supported because Lambda is pure application related. Okay, but application load balancer can be attached a target to network load balancer. That means if you have an application, millions of requests are coming per second, then first I'll choose a network load balancer. Then back into that, I'm going to choose the multiple application load balancers. Okay, so multiple application load balancers also we are going to support. Okay, so these all like targets what we can add.
Sir, which one is the best one, sir? Which is the
No,
first
that
one?
depends upon your application level. Say your application required authorizations, your application required web application firewall, path-based routings, then better to go for application load balancer. Millions of requests are coming. But other than web-based applications, I have other applications like maybe TCP level, UDP level. So
Like a
both are
YouTube
proven kind of things. But if you have a Lambda as a target, then definitely we need to go for
application.
application load balancer itself. Okay, so like this depends upon our requirement. So hence it's a lot of questions will come, depends upon the what are the differences between network load balancer and application load balancer. Okay, so then, so now here load balancer, application load balancer works at the application layer, the seventh layer of the OSI model. Okay, it evaluates, depends upon those, and it take the decision. Okay, then here it supports for path-based conditions, host-based conditions also, HTTP header-based conditions. These in the next class we'll discuss more. And redirects that one URL to another URL, it can bypass or forward that request. Okay, then Lambda also it supports, and we can support IP address. Both are supported IP address. Okay, then containerized apps also supported, but Lambda is not supported by
Network layer, sir.
yeah, network load balancer. But this will support and authentication authorizations based on the Cognito if you have that kind of requirements. Like application load balancer only supports, it won't supported by network load balancer. Okay, path-based routing, URL-based routing also, web application, and TLS termination also. What is the concept of TLS termination? I'll explain. 1 second. Yeah, hello. Yeah, hello.
Yes, sir, you're audible.
Yeah. So now here, what is one more load balancer will do load balancer will do one thing that is called as TLS termination or SSL offloading. Okay, what is the concept of TLS termination or SSL offloading is by default we don't use a HTTP. We are going to use the HTTPS certificates, and if you use the HTTPS certificates at one point of location, those need to be converted into HTTP. That means your data have been transferred over HTTPS, but at some point of time that should be decrypted. In our environment, we are choosing, okay, say here either ELB or target. The target may be EC2 instance like this. Instead of choosing the target, one of the best method is, you may have thousands of targets, right? We need to configure the certificates in the thousands of missions. Okay, most of the companies will terminate that HTTPS transfer to HTTP. At which location they're going to terminate it? At which location they're going to terminate? We are going to choose our load balancer itself as our termination. Okay, so what is our TLS termination point? Our SSL offloading point we are going to choose?
Load balancer.
In the load balancer. Both the load balancer supports, okay, TLS termination or SSL offloading. There is a slight difference between TLS and SSL. I will explain these also. Okay, normally we will choose the web server, but what is the problem to choose the web server is, we may have hundreds of web servers. That is the reason the best place where we can decrypt the data is, okay, the best place to decrypt the data is
Load balancers.
load balancer. For that, we require the certificates also, and those certificates we are going to use from AWS Certificate Manager. We are purchasing the certificates from the AWS Certificate Manager, and we are going to integrate with both of the application or network load balancer also. Okay, and Route 53 also will use, web application firewall also we are going to use. Okay, so these all like related to application load balancer. Okay, so we'll discuss even the network level load balancing also. So if we go for the network level load balancers, the terminology, okay, so the terminology load balancing or listener, probes, target groups, these all very common for any of the load balancer in the world. The terminology maybe changes in Azure or GCP or local load balancers also, but here the concept is same. We'll have a load balancer. The front end IP is the load balancer IP. The back end is the targets, or we may have group of backend pools like target groups. We'll have listener, and it will be keep on probing. For that, we need the target IP address, port number, and which protocol. Okay. Then network load balancer works at fourth layer. Say suppose if someone asks about the differences, if you tell it works at layer 7 and application load balancer works at layer 7 application load balancer, layer 4 network load balancer means people are not accepting. Okay, so then here what are the terminologies we have for the UDP or TCP level other than HTTP, HTTPS? There are a lot of servers also can do load balancing. And what is advantage compared to classic load balancer also with the network load balancer is it can handle network load balancer can handle millions of requests. And one permanent static IP we can attach to load balancer. That means it won't change. For application load balancer, assigning a static IP address is not possible, but that is possible for the network load balancer. This is one of the important difference for the network load balancer. Okay, anyhow, IP address or instances are supported, containers are supported, or Kubernetes also is supported. Application load balancers also can be acted as the targets to network load balancer. Okay, but one service is not supported. What is that?
Lambda.
Lambda as the targets are not supported because it's pure functional kind of thing. Okay, and TLS termination also is supported, but it's not going to be supporting web application firewalls, web application firewall, and the Cognito user authorizations are not possible. Path-based routing, URL-based routing also is not supported. And very long back, okay, so we have VPC, classic VPC. Okay, that means today in the AWS environment, everyone are getting by default one VPC. That means everyone are getting our own isolated VPCs. But long back, we used to get, okay, so we used to get a classic VPC. Now, classic VPC concept itself is not there, but in those days, if you have any EC2 instances in the classic VPC, then we need to use classic load balancer. But as of now, we don't have classic VPC concept itself. That is the reason people are not using classic load balancer. And if any of the EC2 instance is in the classic VPC, already AWS has already migrated them to their VPCs itself. Hence, there is no concept of classic VPC. There is no concept of classic load balancers. Almost end of life have been declared. Now with the VPCs, it's not recommended to create classic load balancer. We need to design for our application either network load balancer or application load balancer. Okay, so then here if you come to the load balancers in the world, okay, so we have HA proxy is one of the load balancer we can use, or Nginx also we can use as a load balancer. Or if you come to the hardware level, there are a lot of hardware level load balancers also, like F5. F5 load balancer is one of the leading hardware level load balancer. Or Citrix, having Citrix NetScaler is also one of the hardware level load balancer. But these are very expensive. The easiest way of doing the load balancing is using the cloud. It may be AWS or Azure or GCP. The concept is same in all these. First, we'll discuss HA proxy, Nginx. Okay, then I'll explain about SSL termination with the web server. That means on the Nginx or Tomcat, how to do the HTTP termination. Then we'll come to load balancer. Then easily you'll understand the load balancer. Okay, so one assignment what I'm giving is you need to configure the HA proxy. Nginx also will act as a reverse proxy kind of thing. Nginx also. All these days we use Nginx as web server, but what Nginx can do is additionally, it can act as a reverse proxy also. Then at the hardware level, we have two types of load balancers, but hardware load balancers are very expensive because this cost you around $5,000 to $10,000 we need to purchase on the hardware itself. Okay, but compared to that HA proxy, Nginx, FI load balancer, Citrix NetScaler used to do like millions of requests. But AWS is now providing that kind of millions of requests also it can bear. Okay. The new method of load balancing we have is gateway load balancer. So what is that gateway load balancer? We'll discuss. Okay. So in my environment, I don't have two EC2 instances, or targets are not EC2 instances. I have my virtual appliances. These virtual appliances may be my gateways, or maybe VPNs. Two VPNs I have, okay, or customer gateways. I want to do the load balancing at this level. Okay, so this mostly comes at layer 3. Okay, so I have two VPNs. I want to do the load balancing. Say if people, like maybe before COVID, maybe 100 users or 1,000 users only may be connecting from home. They used to connect through VPN. But today, the same company may have 1 lakh users also may be connecting through VPN. Then that one VPN, if they have in their environment, that's maybe not able to bear 1 lakh user connections, then definitely they need multiple VPNs. At that level also, if they want to do the load balancing, then we need to go for the gateway load balancer. But you don't tell you have worked with the gateway load balancer. You tell previously we used to work with the classic load balancer. Later we have migrated to network and application load balancers, depends upon the requirements. Okay, and exposure towards gateway load balancer we have. So like this, we need to tell before going for this load balancer things, we need to configure the HA proxy. Nginx also we need to configure for the reverse proxy. Then TLS termination using. So these all not using AWS way, we are not using. First, we are getting these general topics. Then we will understand load balancer in a better way. Okay.
Okay, sir.
Sure. Next class, we'll discuss Monday class. Meanwhile, I'll share some videos also.
Thanks.
Finish all those videos.
Sir, today video, sir. This
Okay,
video.
sure. Okay.
Thank you, sir.
Yeah, sure.
Thank you.
Thanks a lot. Yeah.